Welcome to my exam video 5. We have an example strand of DNA that will code for a specific 5-amino acid protein. This DNA coding strand is inversely transcribed into mRNA and then translated into amino acids that make a protein. This protein must be folded properly in order to work, and the amino acids that make it each have different chemical properties that make them fold differently. You can think of this like the inside of a lock. A lock has multiple drivers on springs with different length pins that are set in a specific way so that only one shape key can line up the pins correctly. We can use this as an analogy where proteins are the key and each amino acid is a ridge or cut in the key, and the lock, a particular biological process, is only activated by correctly folding the enzyme key. A missense mutation occurs when one single base pair change causes the substitution of an amino acid in a created protein. This one small change could cause the protein to fold incorrectly, possibly making it non-functional. We can apply this to the lock analogy by saying the new amino acid may have different cuts in the key than the original, which would keep the pins from lining up and the lock would not turn. A nonsense mutation occurs when a single base pair change causes an amino acid codon to become a stop codon. This creates a much shorter mutated protein, and we can apply this to the lock analogy by thinking of this as a key that is much too short to touch all of the pins in the lock, causing the lock not to turn. A read-through mutation occurs when a single base pair change causes a stop codon to code for an amino acid. This creates a much longer mutated protein, the opposite of a nonsense mutation. We can apply this to the lock analogy by thinking of a key that is much too long for a lock. The key will fit the lock, but it won't it won't line up with all of the pins correctly, as only the front of the key can fit in, and it might still work, but likely the lock will not turn. And finally, a silent mutation occurs when a single base pair causes no observable effect on the created protein. Though the sequence is different, it creates the same protein. We can think of this like a key that looks slightly different than the original one for that lock, or it might just be a different cut, but it's close enough that the lock will still turn. And that's the end of this video. My references are included here as well in the description. The wild type strands and all of the mutation strands for the mRNA are included in the description as well. Thank you for watching.